Now, we've talked about the different ways to understand, greatest common factor, greatest common divisor, the largest whole number between two or more numbers that can be divided into them evenly. We showed you in the past video. What I'm going to do now is show you two techniques that will allow you to find the greatest common factor. The greatest common factor or greatest common divisor. So we'll go here, finding the Gcf or the GCD, greatest common factor, greatest common divisor. So we'll go here. Let's say I have 4 and 12. And I want to find the greatest common factor 4 and 12. So I'll go here. One way is to go ahead and lay out all the numbers that can be multiplied by. So we can go here, 4 equals 2 times 2 also equals 4 times 1. Let's try 12. 12 has 12 times 1. It has 6 times 2. It has 4 times 3. And if we did it the other way, it'd be, 2 times 6, 3 times 4, and as such. So you look here, we find the largest number. As we look here, the largest number that can be divided into 4 and 12 evenly would be 4. And we can see, we have a 2 here, 2 times 2. That's fine, I have a 2 here as well. So I could go here, and I could go here, or either one, doesn't particularly matter. But notice, 3, no 3. Oh wait, there's a number larger than 2. It's a 4. Therefore, at that point, I choose this. So the greatest common factor, or the largest whole number that we can use to divide evenly both into 4 and 12, is going to be 4. Let's see if our theory or conjecture turns out to be true. In mathematics, we have a hypothesis, as you say. In science, we say a conjecture. So we'll go over here. We'll say 4 divided by that 4 there. Looks like that gives me, okay, so it goes in there evenly one whole time. And then we have 12. 4 sets into that. That goes into 3 evenly. And that's the largest number. Notice if I go to 6, that works very well here, but there's no 6 there. So you can see they don't have it in common, in a sense, so we can't use that number. Let's move on to another technique that involves prime factorization. So you saw a little bit of that prime factorization when I was demonstrating to you the idea that the common divisor is the largest whole number that they share. Let's get a little more explicit or more detailed about it, to the point. So we showed you the first technique just by laying out factors. And notice with the 12 and the 4, the 12 we did 4, 1 times 4, 2 times 2. For the 12 we did 12 times 1. We did 6 times 2, and we did 3 times 4. And notice, largest 1. And early in the video, we proved that as well, so I'm going to leave that up. And the next way to find the Gcf is by using prime factorization. All right, so let's try 4 and 12 using the prime factorization technique. By now, our divisal skills should be flawless, but I'm going to not use my divisal skills because I can see 4 here. So excuse me, I'm going to use my divisal skills, so I'm going to say 2 here. So 2 times 2, we'll go here. I'm going to do 2 and 6, and go here 2 and 3. So we go here, and I might go 4 equals 2 times 2, and then here for the 12 I have, was that 2 times 2 times 3. The important thing when you use prime factorization, you're trying to go ahead and figure out what the greatest common factor is. You want to find the things they have in common, the prime factors have in common. So notice the 12 and the 4 have the 2 and 2 in common. What else do they have in common? You got it, the 2 and 2 here. Notice what they don't have in common. They don't have the 3 in common. Therefore, we don't bring it. So we go down here. I've got 2 here. I've got 2 here. That gives me 4. Or let's go 4 here because I'm not sure you can see there. It's important to realize that I don't do 2 times 2, 4, and 2 times 2, 4, and then 4 times 4. I say, hey, they both have a 2 in common. They both have a 2 in common. The product of 2 and 2 is 4. For many of you, I believe this technique will be the easier way for you to take out. But I just wanted to show you that. Let's show you one that might involve 3 let's say you have, I don't know, 16 here. Well, we can still extend out that idea of prime factorization. So let's erase this here. So notice the fact, let me go back and put these so we don't have any confusion. So notice factors you had 2 times 2, 2 times 2 times 3, 2 times 2 is 4, 2 times 2 is 4, 4 times 3 is 12. So let's do 16 here and show you how simple it is no matter the amount of numbers you have. So is that 4 times 4, 2 times 2, 2 times 2 here. So I'll go here, I'll go 16. 2 times 2 times 2 times 2. So notice the 4, the 12, and the 16 have 2 in common. They also have another set of 2's in common. Notice, even though the 16 has additional 2's, the 12 has no more 2's, and the 4 has no more 2's. So therefore, these have the 2 in common, these have the 2 in common, and the product of it is 4. So once again, even introducing the 16 into it, we can see that the largest number that can be divided into 4, 12, and 16 evenly is still going to be 4, or the greatest common factor in this situation. So I hope that helps you out with 3 numbers. It's pretty obvious if you went out here with 16. Now let's do this here just in case for 16. So 16, 1 times 16, 2 times 8, 4 times 4. But you can see here that even though this has an 8, which can go into this evenly, there is no 8 here. Once again, we can see the 4 is common. So this technique of laying out the factors of the numbers that you're working with works for 2 or 3 or 5 or whatever amount of numbers. The same thing with prime factorization. I first started off with 2. You notice I moved to 3, did the same process, gives me the same result. Okay, the correct answer. What I mean by same result, I mean correct answer. I don't mean 4. It could have been 6 or whatever, but my answer would still be true if I followed the same process that I used with these 2 here. So that is greatest common, how to find the greatest common factor or greatest common divisor using the factoring technique or laying out the factors of the numbers. And then also here, number 2 is your prime factorization. I hope that helps. Make sure to rewind it, go over it again if you still need additional help.